Hello, this is Ms. DB, and today we are going to talk about solving radical equations. We're not going to really do the inequalities part, but it's in your textbooks and you can read about it and learn about it if you want to. A radical equation contains a variable within a radical. A radical is a square root or a cubed root. We can solve quadratic equations by taking the square root of both sides. So if you had like x squared equals 16, you could solve that by taking the square root of both sides. If you have a radical equal to some number, you can solve that by squaring both sides or by raising it to whatever power your root is. If there's no number inside the radical right there, then it's a square root. If there is a number there, like a 3, then you have the cubed root, or maybe you have the fourth root. So if you have the cubed root of x equal to a number, you would solve that by cubing both sides, not by squaring. So you have to do whatever that power is, or that root is in the radical side. So here's what we're going to do to solve these. First of all, first step is to isolate the radical. Get any numbers on the other side, so you just have a radical. Then you will raise both sides of the equation to the power equal to the index of the radical. If there's no little number there, it's a square. And then you simplify. So the cubed root of x cubed is x. You undid the cubed root. And 2 cubed is 8. And then I will add a fourth step to check your answer. As you will see, sometimes these don't work, and you end up with extraneous solutions that do not work, and then you have to say no solution. Or if you end up with 2 answers, sometimes one of them will work and one of them won't work. All right, let's look at some examples. These are kind of fun to do. And the great thing about these is that once you isolate the radical, all you have to do is square both sides or maybe cube both sides, and then you'll have kind of a nice basic equation. So good practice with just some regular equations after you turn this into one. So first of all, we would have to subtract the 5 because here's the radical, square root of x plus 1, and it has a plus 5 added to it. So we subtract 5 and get 11. So now we have the square root of x plus 1 equals 11. Now we'll do the second step, which is to undo the square root by squaring both sides. Now we have x plus 1. When you square a square root, you just are left with whatever is underneath that sign. So now we have x plus 1 equals 121. Subtract 1 from both sides, we get 120. Now I told you should check your work. You can just check it on the side or on scratch paper. They should go pretty quick. You put 120 in for x, and you get 121. The square root of 121 is 11. 5 plus 11 is 16, which is what we had on the other side. So it works, so your answer is good. 120 is the answer. Okay, here's one with a cubed root. Now this means 7 times the cubed root of 5x minus 7 equals 84. It looks really messy, actually simplifies really quickly. The first thing we're going to do is divide both sides by 7. That undoes the 7 times that cubed root. And it's a nice even number of 12. Now we just have to undo the cubed root, so we cube both sides. 12 cubed is a big number, but that's all right. Your calculator can help you find it, and it's 1,728. Now we just solve that little two-step equation. 5x minus 7 equals 1,728. Add 7, divide by 5, and you get x equals 347. And then don't forget to check, plug that back in, and make sure that you get 84 on both sides. And we do, so then we know that we have the right answer, that 347 works. Okay, one more example here. We subtract 4 from both sides. Now you finish this problem, pause the video, see if you can figure out what x would equal, and then we'll come back and check your answer. Okay, so you should have found that the square root of x minus 1 equals 1, and then you squared both sides to get x minus 1 equals 1, or x equals 2. And if you check this, you will find that you will get 4 plus 1, which is equal to 5. All right, here's another one. Pause the video, try this one, and then check your answer. Now in this one, you did not have to add or subtract anything or divide or multiply anything before the root is already isolated. So all you had to do was cube both sides to get 3x minus 4 equals 8, and then you get x equals 4. When you check that, you get that the cubed root of 8 is 2, which is 2 equals 2, so it did check. All right, let's look at some that have 2 radicals. So in this problem, we have a radical on both sides of the equations. That's okay because if you note that they are both square roots. So we can solve this by squaring both sides. When you square the right side, you have to square the 3 as well as the square root of 3x minus 2. That's the thing to watch on this one. So when you square the left side, you just get 7x plus 2. When you square the right side, you'll get 9 times 3x minus 2, because this power of 2 has to be applied to both parts. So it undoes the radical, but the 3 squared is going to stay as 3 squared or 9. Then we can do the distributive property. 9 times 3x is 27x. 9 times negative 2 is minus 18. Then we need to get our x's together. I'll subtract 7x from both sides to get 2 equals, oh, they did it a little quicker than me. I would get 2 equals 20x minus 18, and then add 18 to both sides. There's where they got the 20. So 20 equals 20 times x, divide by 20 to get 1 equals x. To check this one, I'm just going to put it right back in here. So that would be times 1, and this would be times 1. So I'd have 7 times 1 is 7, plus 2 is 9. So I have the square root of 9, which is 3. And on the other side, I'd have 3 times the square root of 3 minus 2. 3 minus 2 is 1. So 3 equals 3 times square root of 1. Square root of 1 is 1, so 3 equals 3. Or you can, here it is written out bit by bit. Okay, here's another example, and this one is on your worksheet. So again, these are both square roots, so you can go ahead and square both sides to start it. Remember that when you square on the right side here, you have a number, a constant, in front of the square root of x, so that will be squared as well. So we get 8x plus 6 equals 9x, and then we would, let's subtract 8x from both sides, and we get 6 equals 1x. Well, if you want, you can divide by 1, but that's just 6. And then we check our answer by plugging it back into our original equation. And even though we get a root, that's okay. We get 8 times 6 is 48, plus 6. 48 plus 6 is 54. And 54 is equal to, the square root of 54 is equal to the square root of 9 times the square root of 6, because 9 times 6 is 54. The square root of 9 simplifies, so we get 3 square root of 6 on the left side. On the right side, we plug the 6 in, and we just have 3 square root of 6. Another way that you can check this one is with your calculator getting a decimal number on each side. And even though it's not going to be a nice, neat number, your decimal should be exactly the same. Isn't this, oh, it says number 6 on the worksheet, but the last one was number 6 on the worksheet. So I wonder if this is number 7 on the worksheet, or else it's just another example. So we have the cubed root of x plus 6 equals 2 times the cubed root of x minus 1. So if we cube both sides, you have to cube the 2 and the cubed root of x minus 1. So 2 cubed is 8 times x minus 1. On the left, we just get x plus 6. So then we distribute, and we get 8x minus 8 on the right side. And then we need to solve for x. So 6 equals 7x minus 8. And these answers, most of them, except the last one, was a square root, but a lot of them are coming out nice and neat. They don't have to, though. Your answer can be a square root, or it can be a fraction, or it can be a decimal. Once you get your answer, plug it back in and check your work. And it turns out that the cubed root of 8 is 2, and 2 times the cubed root of 1 is also 2. So it does check, it works, and we can move on. All right, so this one says that we are going to check our work, which we've been doing all along, but that sometimes you might get extraneous roots, which are not solutions. Generally, this happens when we square or cube a side with a variable. Let's look at this example. We have the square root of negative 3x plus 33 equals 5 minus x. So we're going to go ahead and square both sides. Oh, they're first going to use a graphing calculator to look and see what they think the solution will be. They see that there's one solution at negative 1. But when we solve this algebraically, we might find 2 solutions. So we're going to square both sides. When you square 5 minus x, that's the same as 5 minus x times 5 minus x. You can use your special formulas for a perfect square here, or you can just multiply 5 times, do FOIL. 5 times 5 is 25. The outer would be minus 5x. The inner would be minus 5x. And the last term times the last term would be plus x squared. This does not equal 25 minus x squared. You don't just square both parts. There will be a middle term. So we get 25 minus 10x plus x squared. So we write all that down. The left side is just undoing the square root, so we get negative 3x plus 33. Now we want to set this equal to 0. So let's see, we could add 3x to both sides. And we could subtract the 33 from both sides. And it all simplifies to x squared minus 7x minus 8. Now we have to factor that. So you write your 2 sets of parentheses. We've been doing lots of factoring, x and x. And then look for the factors of negative 8 that will equal a negative 7 when you add them. I found it pretty quick because I was thinking ahead that I would need a negative big number to get to that negative 7. So I write x minus 8, x plus 1. Once you have both your factors, you set each of those equal to 0, and we find that either x is 8 or negative 1. Now, one of these will work for sure because we just saw it graphed, but the other one is probably going to be an extraneous solution. So we take both of our answers and we plug them back in and we check. When you put 8 in, you get negative 24 plus 33, which is 9. The square root of 9 is 3. But on the other side, when you plug 8 in, you get negative 3. 3 is not equal to negative 3. This is not a solution. The other one of x equals negative 1, when we plug that in, we get 3 plus 33 is the square root of 36, which is 6. And on the other side, we have 5 minus a negative 1. Be careful there, which is the same as 5 plus 1. And it is 6. So that one works. The 8 did not work, but the negative 1 did work. All right, here's an example from your worksheet. So we're going to start by squaring both sides. And I'm going to just go right to the algebra one. Square both sides, and you get 2x plus 14 equals x plus 3 squared. That means x plus 3 times x plus 3. There will be a middle term because you have 3x for the outer, 3x for the inner, and that will be 6x for the middle term, 3x plus 3x. So do not write that as x squared plus 3 squared. You'll get it wrong. Now we combine our we get our x's on the same side. We set this equal to 0. I'm leaving the x squared on the right side so that I'll have a positive x squared rather than a negative. And you'll get x squared plus 4x minus 5. Now we factor. Okay, so we set our 2 parentheses up, x and x. What are the factors of negative 5 that would give me a positive 4 when I add them? Not that one, because that would be negative 4. this one will work because when I add 5 plus negative 1, I'll get a positive 4. So plus 5 minus 1. Now we set each of those factors equal to 0. And x equals negative 5 or x equals 1. Now we have to decide if both of those are solutions or if one of them is extraneous, or both of them even could be extraneous. So to do that, we check our work. So we go back to our original equation and we try our two solutions. When we used x equals negative 5, we got 2 times negative 5 is negative 10, which would be the square root of 4, which is 2. On the other side, we got negative 5 plus 3 is negative 2. This is not a solution. Negative 5 does not work because we got 2 equals negative 2, which is not true. When we checked 1, we got 2 plus 14, that's 16. The square root of 16 is 4. On the right side, we got 1 plus 3, which is also 4. This does work. So our only solution is x equals 1. The other one is extraneous, which basically means it's not a solution. So we only use the one that works when we check it. Okay, so we're moving on to the second part of your worksheet, which is when you have fractional exponents, exponents that are fractions. To undo, if you have a fractional exponent, multiply by its reciprocal. So if we have x plus 12 to the 1/2 power, we can multiply or raise all of that to the second power. And the rule is when you raise a power to a power, you multiply. 1/2 times 2 is 1, so we just end up with x plus 12. So in this one, we will raise everything to the third power because that's the reciprocal of 1/3. So you raise everything to the reciprocal of the power that you have. You do not have to do this step of write it as a radical first. You don't have to do that. You can just go ahead and cube both sides like I was going to do right away, which would give you, when you raise a power to a power, you multiply, and 3 times 1/3 is 1, so we're just left with 5x plus 7 equals 27. Then we would finish, we subtract, this is not factoring, this is solving. We get 5x equals 20, divide by 5, and x is equal to 4. Check your work by plugging it back in. This one we can do right here because 5 times 4 is 20. 20 plus 7 is 27. The 27 to the 1/3 power, or the cubed root of 27, is 3. 3 equals 3. All right, in this one, we have 2x equals 4x plus 8, all raised to the 1/2 power. So raise both sides to the power that is the reciprocal of this fraction. So in this case, raise it to the second power. When you raise 2x to the second power, both parts are raised to the second power. So we'll get 4x squared equals 4x plus 8. And then this time we'll be factoring. We're going to set everything equal to 0. So I'm going to subtract 4x from both sides, subtract 8 from both sides. And then there's a 4, a 4, and a 4. There's a 4 common in each of these. So let's factor the 4 out. And then finally, we will try to factor this trinomial. So x and x, and then we need the factors of -2 that will add together to equal -1. So it's either -2 and 1 or 2 and -1. And the one that we want is this one because then we would get a -1 for the middle term. So that means either x minus 2 equals 0 or x plus 1 equals 0. So either x equals 2 or x equals -1. Now we have to check and see if we get any extraneous roots here. So to check, we're going to take our 2 and put it back into both sides of the equation. So we'd have 2 times 2, and we want to see, does that equal 4 times 2 plus 8 to the 1/2 power? So does 4 equal, let's see, 4 times 2 is 8, 8 plus 8 is 16. 16 to the 1/2 is the same as the square root of 16, which is 4, so it works. So that means that this is a good answer. Now the other one might work too. It doesn't always mean that one of them works and one doesn't. Sometimes both work, sometimes even neither work. So let's check when you have -1. So that would mean on the left side we'd have -2, and we want to see what we get on the right side. So that would be 4 times -1 is -4 plus 8. That's a +4 to the 1/2 power, which is the square root of 4. So on the left side, we got -2. On the right side, we have the square root of 4, which is a +2. That does not work. So this answer does not work, and then this is our only good answer here. Oh, we already did the check. Okay, here's an example from your worksheet. This one we have the cubed root. So to solve this, you would cube both sides. You'd write it to the power of 3. You do not have to rewrite it in root form unless you feel like it. So we're going to cube both sides. When we cube both sides, we'll get x plus 5 equals 27. Subtract 5 and we get 22. Then we check our answer by plugging 22 back in here. 22 plus 5 is 27, so we'd have 27 to the 1/3 power, or the cubed root of 27, which is 3, and that does equal 3 on the other side. Okay, here's another example. In this one, we need to divide both sides by 3 before we do anything else. They didn't, but it'll be easier if you do. So if you divide both sides by 3, we'd have x plus 6 to the 1/2 power equals 3. Then I will square both sides, and you'll see that this is an easier problem then, and we'll get x plus 6 equals 9. Subtract 6 from both sides, and you get x equals 3. Now in their problem, they did not divide both sides by 3 first. They squared both sides, which gives them 9 times x plus 6 equals 81. Then they distributed the 9 through and got 9x plus 54 equals 81. Subtracted 54 from both sides. And then finally divided both sides by 9. We both got the same answer, but I noticed that dividing by 3 right away would get me to the answer quicker. So there's more than one way to do these problems, just like in pretty much all of our math problems. So that's it. This worksheet is kind of fun to do. Lots of practice solving equations and some practice with roots as well. Thank you very much, and let me know if you have any questions.